morning, students. Today we are going to discuss about digital electronics. Okay, students. In last class we discussed transistor functions, right? So transistors act as a switch and amplifier and oscillator, right? Okay. So now we are going to discuss about digital electronics. Shall we go to the topic, students? Right. First, a small information. Right. See this boxes 0, 1, 1, 0. Yes. So 1, 0, 1, 0. There are two numbers 1 and 0. Right. Now, so why we are presenting 0, 1 and here? It's very simple. A computer understand information composed of only zeros and ones, right? A computer understand information composed of only zeros and ones. That's why we are taking zeros and ones, because the decimal number system is convenient for the programmer. At the same time, the computer uses binary digit for its operations. That's why we used here zeros and ones. Okay, students? Right. And the numbers, so with are the basic numbers classified into these four types. The first one is binary for computer programmer, binary, decimal, and hexadecimal, and octal, yes, for programming. Okay, students? Right. Now the decimal number systems, basically, for example, see that 0, 1, 2, 3, 4, 5, 6, and 7, and 8, 9. But the base is nothing but total amount of number. The total number is 10. Okay. But if you go to this binary number, digits are 0, 1. Yes, 0 and 1. So the binary digits 0 and 1. So what is the base? The base is 2. Okay. Right. Now come to the digital electronics. Yes, see this is one vacuum tube and this is diode, right? So in digital electronics, the electronic transmission was limited to analog technology which conveys data as electronic signals of varying frequency or varying amplitude, right? In 1930, prototypes of computer were constructed from chemical switches and relays, and these were comparatively slow and large and produced the greatest deal of heat. That means it produced the heat. And the next stage in the 1940s was the use of electronic diodes, and while these were better, but they were unreliable. Okay, so this is a general view of first digital electronics, right? Continuation. Digital electronics is a branch of electronics, right? Digital electronics is a branch of electronics which deals with digital format of data and codes, right? Digital format and codes. And digital stand for digit. Digital electronic basically has two conditions which are possible. That means 0 and 1. Okay. And the digital electronic system use a digital signal that are composed of mathematical features to work, and 1 as a true and 0 as a false are called bit, right? 1 means true and 0 means false. these are called bit, and the group of bits are named byte. Okay, the group of bits are named byte, right? Digital electronic circuits are usually made from large assemblies of logic gates, right? And digital describes electronic technology that generates, stores, and process data in terms of two states, one and number 0, one number and 0 number. Okay, students, right? Yes. Here in digital electronics, we use digital signal. Before that, we are going to discuss analog signal, right? See, analog versus digital. See this? So this is the analog clock and this is the digital clock, right? So analog. So analog means continuous waves. Analog means continuous waves. Digital means discrete waves. Digital means discrete wave. Example, an analog clock whose hands move smoothly and continuously. At the same time, a digital clock whose digits jump from one value to the next value. Right? So this is analog and digital. Okay, students? Right. Continuation. Analog and digital system. Many systems use a maximum analog and digital electronics to take advantages of each technology, right? Example, a typical CD player accepts digital data from the CD drive and converts into an analog signal for amplification, right? See this CD drive and digital data which contains digital signal, digital to analog converter, so it converted into analog signal, and this analog signal fit into the amplifier amplify the signal, and that signal is fit into the loudspeaker, produce sound. Okay, right? Okay, students, right? So analog is advantages and digital advantages, advantages of digital electronics. Okay, now come to this one, advantages of digital electronics. First one, computer controlled digital system can be controlled by software. Again I'm telling, computer controlled digital systems can be controlled by software and allowing a new functions to be added without changing hardware. Okay, and second point, information storage can be easier in digital systems than in analog ones, and the noise immunity of digital system permits data to be stored and retired without noise. Okay, and in a digital system are easier to design and more precise representation of signal can be obtained by using more binary digits to represent it. Okay, and next point, more digital circuitry can be fabricated on single SiC chips. And the last point is error management method can be intercepted into the signal path to detect errors and then either correct the errors or at least ask for a new copy of the data, right? So we should know advantages of digital electronics. Okay, right? Now, so recently many types of devices have been converted from analog to digital. Yes, just see the difference between analog signal and the digital signal. See the analog signal, landline communication, elementary radio navigation, and analog indicators. The analog signals used in landline communication and the elementary radio navigation and analog indicators. But if you go to the digital side, internet based communication, satellite navigation, and digital indicators. Okay, and in all these devices, information is processed, transmitted, and received as long as strings of ones and zeros. Okay, right. Disadvantages of digital electronics. What is the disadvantages? See the first one, conversion of digital format and reconversion of analog format is needed, which always include the loss of information. And in some cases, digital circuits use more energy than analog circuits and to produce more heat and need heat sinks. Digital circuits are sometimes more expensive. Digital circuits sometimes more expensive, especially in small quantities. Okay, so these are the advantages and disadvantages of which one? Digital electronics. Okay, now you should know that is digital and which one? Digital and analog. Now see this first one. Analog signal means one whose in output varies continuously in step with the input. See, this is that input, this is the output. But if you go to the digital signal, one's whose output varies at discrete voltage levels, commonly called as high or low. That means high means 1 and low means 0. See the digital, so this is the wave format, either high or low. Okay, right. Why digital signals we used? Why here digital signals we used? First one, data can be stored and data can be used in calculations compatible with display technologies and compatible with computer technologies. Systems can be programmed and digital IC families make design easier. That's why we used digital, right? Why analogs signals used? See this? Most real world events are analog in nature, and analog processing is usually simpler. Analog processing is usually faster, and traditional electronic systems were mostly analog in nature. Okay, and now how it's made. See this first point. At any point in the circuit, only two voltage states are present. That means high or low, and also sometimes called true or false in Boolean logic, zeros and 1. Generally, if it is taken 5 voltage, consider as high, and while 0 voltage consider low. Okay, right? And come to the definition of analog signal. See, this is the analog signal. So an analog signal is a continuous signal that contains time varying quantities. Right? Okay. And next, examples for analog signal. See the first one. An analog signal can be any time varying signal, and minimum and maximum values can be either positive or negative. They can be periodic or non-periodic, and sine waves and square waves are two common analog signals. And next, note that this square wave is not a digital signal because its minimum value is negative. and examples, video signals and audio signals are analog signals, right? So this one is a sine wave and this one is a square wave and this is the random periodic wave. Okay, right? Do you understand what is digital signal and analog signal? Right. Analog transmission. So we can transmit the signal from one place to another place, no? That's why we are analog transmission. See, the transmit analog signal without regard to content. Attenuation limits length of transmission link, and cascaded amplifiers boost signals energy for longer distance but cause distortion. And analog data can be tolerate distortion and introduces error in digital data. Okay, this is the few points in analog transmission. Okay, right. Examples of digital signals. Okay, previously we discussed example for analog signal. Now we discussed examples of digital signal. Okay, see, this is the digital signal and this is the digital signal and this is the digital signal. Yes, okay, see this. Digital signals are commonly referred to as square waves or clock signals. And next, their minimum value must be 0 volts and their maximum value must be 5 volts. They can be periodic or non-periodic. The time the signal is high can vary anywhere from 1% of the period to 99% of the period, and the text and integers. Okay, these are the examples of digital signals. Okay, students, right. Digital transmission. Yes, few points about digital transmission. See the first point. Concerned with the content of signal, attenuation endangers integrity of data, digital signal. Okay, and from this one, repeaters achieve greater distance. Repeaters recover the signal and retransmit. Okay, this is the few points from the digital transmission. Okay, students, right. Now I'm taking that both analog signal and digital signal. See, the first one is with signal, analog signal, and the second one is with signal, digital signal. See the digital signal formation and analog signal formation. Okay, students, this is the difference between this analog signal and digital signal. Okay, right. Now, book definition about digital signal. See this. Digital signals are signals which contain only discrete values of voltages. Right. And digital signals need two states. One is switch on and off. Okay, right. And come to the next one. If it is positive and negative logics. In digital systems, there exist two voltage levels. In 5 means high and 0 means low. In a positive logic system, a binary 1 stands for 5 voltages and 0 stands for 0 voltage. And while in negative logic system, 1 stands for 0 voltage and 0 state for 5 voltages. Okay, this is the positive and negative logics. Okay, students, right. Now see this positive logic and negative logic. So in positive logic, so 0 means and 1 means 5. And here in negative logic, 0 means 1 and 1 means 0. Okay, positive and negative logic. Okay, students, right. Next, Boolean algebra and logic gates. So logic gates is nothing but device, right, to process the which one? Binary is numbers. See this logic gate. Logic gates perform basic logical functions. So logic gates perform basic logical functions. They are fundamental building blocks of digital integrated circuits. The integrated circuits called as ICs. And next, most logic gates take an input of two binary values and the output as single value of 0 or 1. Some circuits may have only a few logic gates, while others, such as microprocessors, have millions of them. And there are 7 different types of logic gates which are outlined. 7 logic gates are outlined. Okay, that means the logic gates totally 7. Okay, right. Now just see this logic gates. Basic logic gates is, see the first one is NOT gate. This is a symbol. I'll tell you the is explained yes what is the gates and their functions later. Now you should know what is the types of gates. This is basic logic gates are NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate. XOR gate means exceptional gate. Okay, okay students, right. Now do you know the concept of high and low is not a new one. In fact, it was applied in telephone switching circuits by S. Shannon in 1938. Okay, so this is the extra information. Okay students, right. Okay, next, Boolean algebra. So Boolean algebra is a what formula? It contains Boolean constants and Boolean variables and Boolean functions and Boolean theorems. So Boolean algebra contains these topics. What are the topics? Boolean constants, Boolean variables and Boolean functions and Boolean theorems. Come to first one. The Boolean constants are 0 and 1, and Boolean variables, the variables that can only takes the values 0 and 1. Boolean functions, each of the logic function, yes, such as and or not, are represented by symbols as described above. And Boolean theorems, it is a set of identities and laws. See text for details. Okay, this is for Boolean algebra is contents, right. Thank you students. I'll explain what are the logic gates and their functions, input output circuit symbols, okay, working function, all the details in next class. Okay students, today class is over. Okay students, just you have to go through the digital electronics side. Okay students, right. Thank you students, see you on next video. Thank you.